Welcome to the Retro Junction.
Hey guys, welcome back. It's been a while, obviously, since I released a video. I've been pretty busy working on some different projects. This is one of them, and then the other one I'll have out hopefully soon. It might be like a month still, but I'm working on a board for the Atari ST computers, but we'll get to that later. Anyway, what we have here is the 2364-3216 universal reprogrammable replacement ROM. It's a mouthful. Version 2. I don't know if any of you guys watching, if any of you ordered that board, the original, the version 1 board. If you noticed, the SST39SF010A just got obsoleted in August of 2024, which is, of course, my luck. So I was working on the version 1 board. I ordered the first 39SF010s and sockets, you know, all the parts. I ordered those around July of 2024, and they were readily available. And I've used that chip in work before, and it's a really small package, which obviously you need because this thing's the size of a 24-pin mask ROM, and it's tiny, so you need all the real estate you can get, especially if you only want to put components on one side, which was an important feature for me. So it can look as much like a, you know, the original chip as possible. But anyway, so I got the version 1 board designed and got it working, was really happy with how it turned out. It seemed to work in everything I tried it in. And then when I got back on to order some more chips, I noticed that nobody had them. I was like, well, that's weird. So I was poking around, then I found the obsolescence notice from Microchip or Atmel, and that kicked off this one. So I decided, you know, I could have left well enough alone, but the other problem is that not only is that chip, has it gone obsolete, and relatively not that long ago, right? It was relatively recent that it went, obsolete. But even with that, you can't find them. Some of the places I would normally go for obsolete chips didn't have them. I was able to order 100 of them from Mauser. They actually had it to where if you searched for, say, 39SF010, it would show the ones that are still active, which are, if I remember correctly, the 39LV010, which is a 3.3 volt chip. But if you typed in the exact part number of the one that I was using, it popped up, and they had, like, I think it was like 150 of them. So I got 100 of them just to have in stock, because the other thing that's beautiful about the 39SF010 is they're cheap. That chip was like $1.50 you could get them for, which is obviously, you know, very, very good price for an EEPROM or an EEPROM, in that case, flash ROM. Even the, you know, 27 series chips, the one-time programmable ones, cost like $3, $3.50. Anyway, so I had to pivot, and I decided to go ahead and try to make a new version with a chip that wasn't obsolete, because, like I said, it was, not only were they obsolete, but they were seemingly hard to find aftermarket, you know, not aftermarket, but third-party vendors for them. You know, there was some on eBay, but they wanted like $9 or $10, which is just insane for a chip that literally a couple months before that you could buy brand new from from the manufacturer or one of their distributors, a known good source, for $1.50. And now all of a sudden, you know, they want $1.50, or sorry, $9 or more to get them from China or whatever. And then you don't know if they're going to be real and all that. So it made me want to go ahead and redesign the board with a new chip. So I did that, got into that, and ideally I wanted to try to find a cheap chip. That was, you know, that was one of my big criteria. I wanted to find a chip that was cheap, just like the 39010, and I needed to find a chip that would fit in this package, and that proved to be pretty difficult. I also didn't want to get a chip that was like 4 megabits or whatever. There's no benefit that I can see to that kind of a size on these old machines. All it would mean is that if you're doing it, if you're programming it in the way that many people do, where you have to program the same program into the chip multiple times to fill up the different sectors. Well, if you're doing it with a 4 megabit chip, you might have to do it like 60 times or 64 times or whatever it ends up working out to. So I wanted to get something, 1 megabit or smaller, like the original board used. But anyway, so this is what I came up with in the end, and I can't say that it's too amazingly inspired. I mean, I literally scoured, up and down trying to find different chips, but I ultimately ended up having to go with the 28C64 EEPROM, and I can't remember, I can't see it, let me look. Okay, yeah, so in this case, on this particular one, you see it's a 28C256, and that's worth talking about. I did all the connections and I set it up so you could use the 28C256 or the 64, sorry. And I did that mostly for anybody that's going to be concerned with or want to do ROM switching. So in the case of the 2864, for like a Commodore 64, well, say you're aiming to replace a 2364, right? Well, the 2864 is the exact same size as the 2364, so you don't have to split it. But obviously then if you want to do ROM switching, well, you can't, because that one file takes up this entire chip, or the 64. So I set it up and did all the connections to allow you to use the 256. That way, in case you do want to do any ROM switching, you can hook up wires to the Pogo Pen target pads here to give you access to the address lines. I don't know if you can see it. I think you can. They're labeled there, 13, 14, and you have output and write enable. But I'm not going to go through, all of the, like, showing you on different machines. This board, by design, on purpose, works in every system that the original version 1 board worked in. The only real difference is that it's not 1 megabit. The highest you can get is 256 kilobits. But that's 4 times the size of the largest chip that this is intended to replace, and then that gives you obviously a few extra slots if you do want to do any switching for different ROMs or whatever, like Jiffy DOS or whatever. I haven't really got into that much. I tested the ROM switching and it works obviously, but I haven't really had a use for that. But anyway, I'll show you it working here in a C64 as the kernel here in a minute. But one thing I did want to point out, just so you guys all know, is I did make sure that the jumper configuration, the jumper settings, they're laid out and function the exact same way as they did before. So for example, the configuration that this is currently in is the one that you would put it in for programming, for programming to this chip, to the 2864. And in the shared projects file, I'll have a link below to the PCBWay shared projects. I put example jumper settings for you guys so you can get an idea of what does what. But yeah, other than that, it's functionally the same. I guess one thing that's worth pointing out is I use these smaller Pogo pins, and the reason I changed it like this was because this chip, even though it's a quarter of the size of the 1 megabit chip electrically or electronically or whatever, memory wise, it is quite a bit larger in its physical layout, so I couldn't get the pins to sit down the side of the chip like I did on the original version. Here's that. With the regular 2.54 millimeter pitch Pogo pins. So I had to get a little creative, and I ended up putting it to where they they sit in the gap in the socket on the programming adapter. The programming adapter is different between the two boards, so you will have to get a programming adapter made again if you had already got some of the other boards, because obviously physically it's totally different. Different Pogo pins, different pitch, different socket even. That's one thing I did want to point out for everybody. You'll have to get the parts that are in the BOM on the shared projects page. You won't be able to, well, with a little bit of a caveat, and I'll show you an example, but get everything that's in the BOM and you can make this version that I have here, which is the shortest version I could make with parts that I could find that are readily available through Mauser or DigiKey or whatever. Just like before, it, you know, just slides down and stabs my fingers really bad, but yeah, it slides down, makes contacts with the targets, and then that's how you program it. And then when you're done, you take it off, set the jumpers if you have to, and then just toss it in your machine and you're good to go. One thing I noticed, I'll point that out while I'm thinking about it, is I tested this on an IBM 5150, which has 2364 equivalent chips. I don't remember what they're actually called, but same pinout, same size, whatever. On the version 1 board, if you were replacing a 2364, you would just set these two jumpers in the position that you see here, which is nice. So after you program it, you didn't even have to change the jumpers. But with this one, for whatever reason, I'm guessing it has to do with the internal address lines to the chip, if they're pulled up or not. But for the 5150, I also had to close jumper JP3, which connects output enable and chip enable together. Otherwise, I think it was output enable would be left floating, and on this chip, it doesn't get pulled either direction, I guess is what's happening, because it won't function unless you tie those two together. Now, you know, just be aware of it. On the C64, that wasn't the issue. As a matter of fact, I didn't have that problem. I don't even know if you would call it a problem. And technically, they should be connected because you don't want your output enable pin to not be connected to anything. But on the other chip, it worked, no issue. On this one, it seems to have an issue with that on some machines. But on the C64, at least on the ones I've tried, I didn't have to do that. It will work just like the version 1, where you only have to set JP1 and JP4. Okay, anyway, so here's these two. They're identical functionally to the other one, except for the size difference, the ROM size difference. And then I'm going to show you this one. As far as using some of the parts that you had from the version 1 board, it can be done. I don't have this information on the shared project site yet, but if I figure out how to do it, maybe I'll put it on there, or I don't know, put links to the parts in the description of this video. I'm not sure yet, but this is the same socket from the version 1 board, and these are the same turn pin headers, SIL headers, that were from the version 1 board. And the way I was able to make that work was using you can barely see it there. Well, I guess you can see it. Let me grab something to point with here. I used a 2mm pitch socket, single inline 4-pin socket. You can see it down there. And it works fine. The only issue that you could have with it is it does give you this little bit of play, but from what I've seen, it works just fine. You just make sure that it's straight when you put the chip on, and you won't have any issues. But that would allow you to use some of the parts from the version 1 board if you so wanted to. The downside, of course, is that it would sit up higher. so it would sit higher than other chips that were in sockets on your C64. If you use this one, it's almost the exact same height as a regular chip. So if you had this in a socket next to original 2364s, say in a C64, this will be almost the exact same height. There are some headers that you can use to make it basically the exact same height, but you can only get them from Germany, so I wasn't going to bother putting the part numbers, because then you got to pay crazy shipping, and the parts themselves, they cost nothing. They're little pin headers. But if you wanted to if you just want to buy a few, it's going to cost you $50 in shipping or whatever. But anyway, yeah, I just wanted to point that out to you guys, that if you did want to use your original header pins and your original sockets and everything, you could. You just you'll have to get this little, the little socket here, the little pin strip socket or header socket, whatever you want to call it. I'll put a link to that socket in the description below, in case any of you guys do want to do that, because that's really the only thing different that you have to do, is you have to use that socket to get it to go up high enough to make connection. I couldn't find these Pogo pins any taller than what these are, so that's kind of what I had to work with. And then beyond that, the parts are exactly the same, other than the chip, obviously, but the little dual inverter is the same. The resistor network, now I can't say they're exactly the same. There's less parts on this one because it had less address lines, so I didn't need the other resistor pack and then a couple of resistors that were unneeded. Or sorry, no, resistors, I think that was it, resistor pack, I don't remember. But anyway, if you bought all the parts to build the version 1 board, all the chips up here you would already have, or the chip and the capacitors and the resistor network, resistor array. That's about it as far as, any of the details on the thing. If you use the other one, its functionality is identical. It looks identical from the top side. I mean, obviously the traces are in different places and whatnot, but it's exactly the same size, physically, same dimension, same size, same silk screen and all that. So from the top it will look the same. Functionality wise, it's the same. The only difference, and an important one that it is that you can still buy this chip. Now, the downside to this chip, and the major downside to it for me, one, that it's bigger, so I had to work, took me a lot more trickeration to get all this stuff crammed in to this board, with this chip being like twice the size. But it did help because there's less address lines. I didn't need as many parts, so that probably made it possible. But the major downside to this chip is that it costs more. The 256 one is like $12, which is kind of insane, but that's just what it is. And then the 64, the 2864 version, I think is like, I think it was like $7 or $8. You might be able to get, cheaper, better deals from eBay or whatever. But as far as DigiKey, Mauser, Newark, whatever, that's about what they are. So it sucks because they're, many times more than the SST 39010, but it's the only one that really fit everything that I needed, and would fit physically. And unfortunately, and I don't really know what the story is, the deal behind this, but they do make a version of this chip in the TSOP pin package. So this is SOIC. They're bigger by quite a bit. TSOP is smaller. It's harder to solder. So one benefit to this for the average person or whatever is this is a lot easier to solder than the version 1 board, because the pins are much wider pitch, right? But as far as real estate goes, if I could have gotten I think it was a 32 pin TSOP, it might have been 28 pin, but if I could have gotten those, I would have used it. But you can't buy them readily available from Mauser or DigiKey or whatever. I don't know if they quit making that variant or what, but you just can't get them. So I went with this one, and I'm happy with it. It looks nice. It functions exactly the same. I am happy with the results. It's just one of those things where it's like, man, that's my luck there. I finally got the first one right where I wanted it, perfect. Like, I was really happy with that design, and then Microchip, you know, obsoleted my chip, which is unfortunate, but here we are. Okay, I'm gonna move the camera and throw this thing in my C64 just so you can see it boot up. Like I said, I'm not going to go through all the different configurations. It's exactly the same. So give me a second. All right. Let me lock the focus. Okay. I put the board in my C64. I programmed it with kernel version 3, the last one for the C64. Like I said, in the case of the C64, I didn't have to set jumper JP3 to connect the output enable and chip enable, although you could do that, and it will work that way. That's probably the way you should do it, but for whatever reason, you don't have to do that on the C64, or at least my C64 and chip configuration. But anyway, it's in there, it's programmed, and it's, let's fire it up here and see what we get. All right, and yeah, there you go. Just like the original one, it functions exactly the same. I think it's 8. Yeah. Everything works as intended, just as if you had an original, you know, 2364 mask ROM. Just like the original version. Everything's fine, everything works the same. I haven't had any issues with it. I tested it in all the same machines that I tested the original version in, and it works just the same, aside from the output enable and chip enable on the 5150. For whatever reason, the version 1 board you didn't have to set jumper JP3, and then this version 2 board you did. But like I said, technically you probably should close it in that case anyway, just so you have output enable in a known state. But that's it. A little bit of a shorter video than normal. You know, again, sorry I've been gone for so long. Thanks for, you know, not unsubscribing and whatnot. But I've been working, this project's been done for quite a while actually, but then I got an Atari ST and started working on the next project that I'll make a video about, and I've been working on that for quite a while, on version 2 technically of that board, but you'll see that later. As always, thanks for subscribing. I really appreciate it. Thanks for watching the video. In the link below, you'll find the links, or excuse me, in the description below, you'll find the links to have this board produced. The links are for PCBWay, but you could send the Gerber files wherever you want. All right, thanks guys. Bye.